Yeah, hello everyone. So today we're talking about precision in e-commerce search. We'll start with a quick introduction of ourselves and the company we're working for. So this is Jens, he's a software developer at our search team and the technical lead. I'm Arne, I'm a product manager and the business lead of the search team. Some few facts about Otto in case you don't know. Otto is a retailer with a rather long history, founded in 1949, emerged to one of the biggest online shops in Germany. We have around 3 million items in the shop at the moment. And these items come from all the different departments. We have like fashion, electronics, furniture, toys, basically you name it. And we are planning on becoming a marketplace, a platform soon, so we expect to be growing fast in the coming years. Some key facts to our search. We have like roughly 1 million search queries every day. On special days, we have peaks to up to 3 million queries. And one of the numbers I like the most on this slide is the 40 millions on the lower right side, the unique search terms in 1 year. It shows the complexity we are dealing with, 40 million different search terms every year. So we won't get bored anytime soon, I guess. Last slide of the introduction, just in general, what's our goal in search? So we want to balance the user perspective and the business perspective. And for these, we have 4 key factors. So of course, the user query and the product data, that's what we're using in basic text matching for the topical relevance. And for the business side, we have different performance indicators for the products like turnover or margin. And for each category, we set different goals, or we can set different goals. So for example, in the fashion department, maybe we want to optimize for turnover, and electronics maybe go rather for margin. So now we get started at the beginning. So what is the problem we want to solve? We have a lot of queries, which is quite a nice recall, but there's also a lot of noise in it. And that's what we're going to talk about today. This is causing 2 kinds of problems. The first one is problems with our filters, and the second one is problems with our ranking. We start with the filters first. So this is our search result for TV. It looks kind of okay. First page full of TVs, nothing to complain about. But when you look a little bit deeper, it's like 4,000 hits. And when you check the category filter, you see from these 4,000 hits, only 400 are real TVs. So that is like 10%. That makes up like 90% of potential noise or irrelevant products in this search result. And we have 2 problems with this in our filters. The first is the noise in the search result is reflected in the filters. We have a lot of filter values that don't seem very suitable, like fashion when in the search for TV. And when you imagine you're a user, you want to look for a TV, you go to the brand filter and you want to check what kind of TV brands do they have. And you have 90% of non-TVs there. There will be a lot of brand names not connected to TVs at all. And the second problem is the absence of relevant filters. The most relevant filter for this query is the screen size. And we are not showing this filter because we have some kind of coverage rule to not show all filters at once. So you need a certain coverage of products to show a filter. And since we have so much noise in it, we won't show it. The second part of the problem is the ranking. This is our search result for Thai. And as you can see, is not the best. There is at least 1 Thai in the first 6 hits, and you can somehow figure out why the other suits are in this result, but it's not a good result. It should look something like that, probably. Why is that? That is connected to our mixing up topical, relevance, and business values. So what you see here is our Solar preview. We use it for debugging, and then we have a plot. In this plot, you see the blue dots. This is like the relevance score. and you have green dots. This is like the business value of the products, and the x-axis is like the positions in the search results. So the two dots on the left is like the relevance score and the business value of the first product. And basically the ideal, it should look like you have a flat line of blue dots with all the relevant or nearly relevant products, and then the green line should slowly decrease. So in the end you want the relevant, most successful product to be on the first position and then slowly decreasing success rate. And the mechanism we are using for this is working kind of okay, but we always get problems with outliers. And this is the example for outliers. So you see the first suit that's on position 1, it got the relevance score is not very high, but it got an outstanding business value. So that is an outlier that kind of fucks up our ranking. And yeah, so that's basically the problem in our ranking with the irrelevant products and the lack of precision we are having. So before we get started with the solution, I want to take a small detour because just seeing, okay, the facets are not good and maybe there are some irrelevant products. When we want to fix it and we want to go to an A/B test, we need to think about what is the KPI to measure our success. And for that, we have to think about how is it going to affect the user. Is it like, I don't see a filter, so I run away and don't use the shop anymore? Or what's going to happen there? And for that, we take a small detour first to our business objectives. The first one is search effectiveness. So in the end, most of our searches are transactional. We're an e-commerce shop, people want to buy stuff. So when we have a search session with an order in it, we basically take that as a sign of success. You see here, the first one is a successful search session. Looks like the user comes in, he's interacting with the search, he's like searching, filtering, paging, this kind of stuff. In the end, he buys something, so that is like a successful search session for us. And below that, unsuccessful search session is like user comes in, searches, pages, but in the end he doesn't find what he's looking for, so he leaves. And for the search effectiveness, the KPI we use is the search conversion rate. Probably most of you guys do the same. The second business objective, we call it the search effectiveness. So this, we only look at the successful search sessions, and our goal is to make it to reduce the effort the user has to take as far as possible. So you see the same search session as before. It's like 5 search interactions, and somehow in the end they buy something. And then on the opposite, you have another search session, and the user only needed 2 search interactions to get to his offer, so to his order. So that is something we regard as a better search session. And the KPI we are using to measure this is the ratio of the number of search interactions to the search orders. So, and with these 2 KPIs, we can build our hypotheses for the test. The first is regarding the search effectiveness. We assume we have some users with a rather low involvement in either the search task or our online shop. So let's say someone wants to buy a TV. He comes to our site and sees the not so well search result. It's a bit complicated to find what he's looking for. So in the end he says, no, it's too annoying. I just leave the shop and I go to buy it somewhere else with a better search. And so that's the first hypothesis. If we improve the precision of the search results, these kind of customers, we can make them convert and we can make them place an order. So that's the point where we can really earn some extra money. The second part is the second hypothesis is the search efficiency. We assume again there is another kind of user. He got a higher involvement in our shop. He's a recurring customer and he's also looking for a TV, for example, and he's not stopped by some irrelevant products or some missing filters. He's eager to buy this thing, and so he's fighting through the session to buy the TV in the end. So this kind of user, if we improve the precision, we won't earn more money with this user. But what we can do is to improve his search session, give him less effort, less clicks, less thoughts. For him, it should be easier to find it because there is less noise in the results. So basically, that is the second hypothesis is improvement in precision will lead to a lower ratio of search interactions per order. Now we will talk a bit about the approach we took to build this solution. And first, I'll explain how we do discoveries at Otto. We roughly follow the design thinking process. So we have three phases. The first one is the understanding the problem, then finding the solution, and in the end testing the solution. Understanding the problem is basically, it starts with a business understanding of the problem. That's roughly what I just told you. You think about what is the problem, what are the details of this problem, how is it going to affect the user, and really define some KPIs. That's all business understanding. And then you follow up with a data understanding. So you basically check, do we track everything right? Do we have enough data to look at this? So like a very rough overview of how do the data look like? How many queries are influenced by this problem, and how big is the potential? Then we go on with the finding the solution. That kind of starts with the ideation phase where we brainstorm ideas, and then we normally pick like one or two possible solutions to follow up with. And after that, we do a data deep dive. That is, depending on the solutions, you really go deeper in the data. You check, do we have the data? Is the data clean? Do we have to do some kind of data cleansing first? What data fields can you use for this? And this kind of stuff. Once we did that, we built some kind of prototype. And after that, we do some kind of offline evaluation. That's like a framework we built where we use judgments generated by clicks to calculate search metrics. And we use these metrics to evaluate our solution. And we can also use it to make some decisions for the solution. So we can narrow down the possible amount of solutions. And before we go to the A/B test, which will make us faster in the A/B test because you need lesser groups for that. So in the ideation, that's basically where we found our solution. Now we just mentioned the solution we are following up with. And the idea is pretty basic. So the question is, we want to raise the precision. So we have to ask ourselves how to find out which products are relevant and not, because the pure text matching isn't enough, obviously. So we have a lot of data that do interactions with products. And we can use that to determine which products are relevant and which are irrelevant. So we look at the clicks and orders of the people. We can see which products in a search term and in a search result are being clicked, and therefore we know which of these products are relevant. And we can do some kind of aggregation for this. So we can, for example, the TV query, we have a lot of people, like 90% of the customers who search for the TV, click on products that are actually TVs. And then you can check, okay, what do they have in common, which data field, and that is probably the category TV. And then you can use this category to automatically filter the result once someone enters the query TV. So that is roughly the overview, and that's the solution we followed up with. And it took us like 4 iterations to finally come to the real prototype. So first, this is all about like scope and which type of queries we are going to influence. And the first part is we started very simple with brand searches. We thought that's very easy to grasp. They are easy to find in your query logs. And then we checked the potential, and we find out in these kind of brand searches, they don't have a very big problem with the precision. Maybe because the brand names are so unique, there is less noise in it. And so we didn't follow up with this, but took a second iteration where we focused on category searches, that is like TV and Thai, and there we saw, okay, we have a big potential there. These are the queries we have the most noise in, so that is very good for us to work on these. And then we took a step step back because we thought, okay, now we only focus on the category searches. How about other kind of searches? Maybe there is more potential in other kind of searches we didn't think of first. And basically, we were starting to narrow down the solution before we even went to the A/B test and let the customer decide what we should do. So we decided to not only influence the category searches, but all searches, and just let the customer decide which is going to work and which is not. So the advantage of this approach is that the solution got a higher potential, but of course you have a higher risk because there might be queries you just break by setting a filter and maybe you kick out all the relevant products and screw up the whole query. But we decided to let the customer decide that we wanted to put this question in the A/B test, and later on we can check the data generated in the A/B test to follow up in the next iteration. And then we started to shape the prototype we built with our offline evaluation framework. That basically means we made some decisions like which data field to use, which cutoff, which metrics, to narrow down the solutions so we have a easier way in our A/B test. And the details how we did this offline evaluation stuff, that's something Jens is going to tell you about.
Hello. So as Arne said, I'm going to talk about the offline evaluation process we are using before we dive into an A/B test, and just remember the setup. So I will talk about the process of designing a prototype and then evaluating this prototype offline so we can decide which configuration of this prototype is going to an A/B test on our website. So first, a few words on offline evaluation and our general setup. So that's what we have said before. So most of you probably do something similar like that. So you have a website, you have something to test on site. So you probably have split into groups, 2 groups or 4 groups or whatever amount you wanted to check. And in search or in our situation, it's a bit it's expensive to do it like that because when you change something and break something, then it's going to be costly depending on how much traffic you have. We have a lot of traffic, so you want to get the things right in the beginning. So we decided to build something like our offline framework, which uses query logs and click logs, and we generate implicit judgments from those click logs. Have something like our offline evaluation setup. I will show the details later. And use this to create relevance assessments of different configurations of our search, and then decide on which of those configurations is going to be used in the A/B testing. So what is the offline architecture? So this is a bit a technical view. I will just quickly go through this and then guide you through what it is. So on the top, what is it, top left, there is all this kind of tracking data we collect from our shop. It could be everything, not just search. That's collected, going into some clickstream. We parse that and use only the search relevant data. So we have another S3 bucket, that's the icon we use here, where all the queries and the click logs are in. And this is actually temporal, so you have time slices for each day, so you can collect the data later on. And on the right-hand side in the top, that's where actually our process of evaluation starts. So we have something like the thing we want to build now for auto-filtering. We decide, okay, what kind of queries we want to use. So we have a query segmentation mechanism, so we can use different features of the logs to select the queries, and then select the time slice we want to use in. Then we take those kind of judgments from clicks and put them into this little cannon on the side, which simply is basically a script or a service that allows us to shoot queries to our Solar clusters, and those are actually a lot of configurations. So for example, we get like 100,000 queries out of this, and then we have like 200 configurations, or maybe 20, so you get 2 million queries, and then you shoot them, and then you have results you get from the hits. You use the judgments to calculate metrics, and the metrics gonna tell you if the solution or the test configuration is better or not. So what kind of metrics we are using is probably everything you already know. So topical relevance metrics are mostly used in our scenarios for reflecting or tracking user intent. So we want to see if the result's going to be better for our users. So typically it's precision, NDCG, average precision, or ERR. And recently we added something to address temporal changes in our frequencies of the data. So let's assume we have, like this, for example, the TV query is going to be a marketing action or a marketing event. So you have a lot of more TV queries than you have in an ordinary day. So you want to reflect this in your query set, especially if you do something, what we are doing right now. We are increasing the size of our offline evaluation query sets, and once you increase the size, you need to sort of account for the importance of the queries as well. So we simply use the traffic weight as the first metric to do that, and you could do actually one more step further. Think about which are your important queries, so you can find a measure to reflect the importance or the conversion rate, for example, of your queries, and incorporate that into your judgments as well. We didn't do the last part, but that's something we are working on in the future. So going back to our auto-filtering problem from the beginning, so remember the TV thing or the tie thing, and in our offline setup, we have, I want to show you what are the different configurations we were testing in the offline circle. So we have different kind of product attributes we can use for auto-filtering. So that's the first line there. So you could use assortment, that's an attribute which has only like 10 attribute values. We could also use categories, which is like thousands of values you have, or we could also use product types, which in our case is like tens of thousands of attributes. So, and the tricky part is how to figure out which of those values you need to use for filtering which queries. And we have also, we showed the data we have, the click data and add to baskets or order data. So we decided we're going to check up what's going to happen with click and add to basket data. And our assumption is, okay, so click data is quite good, has a good availability. We have a lot of click data, but as soon as you go down the channel or the funnel of the buying process, you're gonna have less data. So you need to have something that accounts for that. So we wanted to compare clicks and add to baskets. And the third lane is the filter value selection is a strategy how to select or find the actual filter value you want to do the auto filtering on. And the metrics is you're just going to see in the results slides. Again, we are looking at precision and average precision, or we're looking at average precision and precision. And what we did, we have here, okay, we have three fields. We have two kinds of of interaction data, and we use two different configurations for the filter selection strategy, which I will show you in a moment. Think of this filter value selections like something like that. For the TV example, we have a lot of product types which are related to TVs or maybe not. And what you want to do is try to figure out which attribute values are the ones that you should actually filter automatically on. And in this table, that's the data is of course manipulated so that you can that I can show the examples. So what we do is we use some kind of coverage measure of clicks to figure out which are the relevant attributes. So we create we have the clicks in the second column, we have the cumulated sum of the clicks in the third column, and the coverage calculated over the cumulated sum. So the coverage is basically the cumulated sum divided by the total. So we can use this coverage as a way of means to figure out which are the relevant attributes for each individual query. And we use two configurations, 90 and 95% in the offline evaluation testing. And here are the results of this offline evaluation testing. So each row is one configuration of this offline experiment. So on the left hand side you see the type of attribute, the interaction type, and the coverage value. And what you see, or what we found, is that all our precision metrics improved on this setup. So of course this is on a set of 100,000 queries. So you will see some queries improving and some queries decreasing in performance, and some not changing at all. But on average, this is what's going to happen. What you see there as well is, especially on the right-hand side, the number of queries changed as the blue column is heavily affected by the kind of click data you use. And what we found in our offline testing as well is that higher granularity of attributes seems to be working better, and that click data might be working better as well. That's what I said about the coverage here. So the more you change, the more likely it's going to be that you're going to make an improvement as well. So back to our basic discovery approach. So that's what you were seeing there was like, okay, how can you find the right configuration to test? And now I'm going to show you how we implemented the solution in our on-site search. So the technical integration looks like this. We have a lot of business rules actually in our system, search system, and they are configured through a query preprocessor. We are using a quirky tool from René for that. And those kind of rules are plugged into our Solus system. So going back to our example with the search for tie, we want to avoid results like that, which show something else or something related to ties on the top. So you can use quirky to apply filter rules as well, and that's what we did to use this to implement the solution. So for the tie example, you say, okay, tie should be filtered for product type or filter type name, in this case class ties, and then you get the results like this. So how did we actually figure out which are the queries we want to use that should benefit from the solution? So think about it like that. You can implement an automatic solution, and then remember what Bertrand said. You fix something there, and you break something somewhere else, and you want to avoid that. So we think about how can we avoid this to be a bit overreactive with auto-filtering. So we decided to use a query set of 230,000 queries, which are collected from 3 months of data, and filter those. And those are filtered for no nonsense in the meaning of, okay, we compare just the standard query versus the automatically filtered one, and you don't want to have results where nothing changes. You don't need them. You explicitly want to avoid 0 hits. So, for example, if an attribute selection has disappeared because of stock changes, so you don't have this kind of attribute anymore, you could end up in 0 hits. That's what you want to avoid. And of course, the click data may not be representing anything clear, so you want to figure out how you filter those as well. So that's what we did before. That was some kind of manual step in this process. And the second part was about more like a business-related perspective. So what we found in our offline testing was that we saw interactions with brands, and there's something you really want to avoid as an online shop. If you have a search that contains a brand, and you do some auto-filtering on something like a category or a product type, that would result in not presenting everything regarding this brand. And that would mean, for example, for a user looking exactly for that he cannot find it in your shop, and they would simply exit. because of that. So you want to avoid that, and of course we were looking only into using those queries that had a positive change in our metrics in the offline test. And the third point here is that we had the assumption or have the assumption that auto-filtering or filtering the results to improve precision only makes sense if the result is of a certain amount of hits. So if you only have 30 hits or less, it doesn't make any sense probably. So that's why we have a filter for that as well. And that ended up with 40K filter rules we could simply add into the quirky mechanism and put into our A/B test. Of course, there are a few more challenges. For example, user interaction can be quite tricky. I'm just going to go through this quickly. So what happens here is you have a user who's using a filter, which could be an auto-filtering attribute as well. So if he's doing that, or if he's querying your search engine for ties, and you are using this filter mechanism automatically, you have to think about what's going to happen, because in the end, if he's doing another interaction with, for example, the color, you need to make sure this keeps being set. So if you don't do anything, it could result in that you get black, the color filter for black, and your auto filter will maybe disappearing. So you need to figure out what you're going to do with that. And we decided, because we have a lot of data fields, we can use fields that are not actually able to be used by customers. So we decided to use to avoid this problem by using just another field. And another problem is, of course, you are interacting. We are using interaction data. And we are testing this, and when we are testing this, we are actually changing the database we are using for auto-filtering. So that's something we need to actually take a more deeper look into. What happens if you remove certain attributes to be filtered, and the customer is not going to have, you will not be able to collect any more interactions for those kind of filters. So that's going to be a problem. And another thing, or another example for this is the second point. You could miss trending attributes. For example, in the TV thing example, you could see, let's say 4K TVs was not here like 3 years ago. It's going to be a new attribute. You filter everything what you have in your data, but the attribute appears, then it won't be reflected in your data, so it won't be the customer won't be able to see the 4K products, and that would be a problem as well. So you need to think how you can avoid those two problems, and you also need to think about how you're going to update this data. So probably it's most obvious is probably that you're going to need to have a high frequency of updating your data. And now let's have a quick look into the on-site results. So the first thing is the first hypothesis Arne was talking about was the search effectiveness. And what the dot there shows, we are actually running the experiment. So if you check the queries right now, you would go on our website and you check with your neighbor, you're probably going to see different results. And this is just a preliminary results of 1 week of data. So we see that the conversion rate in the test result is 0.5% less, which is percentage of percentage. So it's not absolute percentage, 0.5%. But of course, it's not what we expected. And for the search efficiency, we see that there is also 0.75% lower rate, which actually means the session is shorter. So it's actually what we expected to see here. So we need to look into the details, and that's actually our process as well. So we use the A/B testing data to figure out what we see there, and then start over again and do analysis on what we can do next. So that's the thing, or one reason we have this offline evaluation tooling as well, because this loop you see here is more expensive than the ones you do here, because those between prototyping and offline evaluation are pretty much really fast, and taking the loop back to something in beginning takes into, you need to run the experiment, wait for the experiment to be finished, wait for the deep analysis of the experiment results, and then you can start and do the next iteration on your problem. And that's what we're going to do in the next few weeks. And I will show you a few more, say a few more words about what could be the next steps for our query filtering problem. So the products and the user interests will change over time. That's what's nothing we can change. So a fixed set of filters like we are using now in our first experiment will not be working in the long term. And we aim at something, a combination of learning components. So one part is identifying the fuzzy queries. So if you have something like a query predictor who is able to, which is able to tell you, okay, this is a fuzzy query, you should try auto filtering or for precision, and or not. And then you can use another system or another machine learned approach to figure out which kind of filters for those queries should be applied. So those are the two components we are looking into in the future. Yeah, that's it. Thank you very much, and we are open to your questions.
Okay, so do we have any questions for Jens and Arne?
Yes. This is very nice talk, thank you. And since I'm coming from e-commerce background as well, I have a very interesting question. How are you supposed to battle this problem between business and the user context? You were showing it in the beginning, right? So selecting auto filters is good for users, but it may hurt these business rules, right, that usually e-commerce sites have, like boosting, let's say, certain types of products or brands for a specific type of query which needs to be solved. So how you plan to address these kind of challenges?
So your question is how we prevent the kicking out of relevant products, or
but also, like, let's say, this business objectives, right? You have this auto filtering which potentially can filter out these business-driven products, let's say.
yeah. So if the mechanism is working right, then we only filter out the irrelevant products, and for them the business side is not to be concerned because they are irrelevant. But the problem is, if you really filter out relevant products, then you might kick out the successful products as well. But that's something you have to figure out in the mechanism, how to set these filters. You just have to be very careful with that. Okay, at the moment we don't have sponsored products, so that's not a problem, and we will have it in the future, but that will be not coming. We will split it up between organic search results and sponsored products, so the filtering will only be in the organic products, and sponsored products won't be hurt.
This could be an approach, right? So you just separate.
Yeah. Okay.
It's not your size. In my experience, conference T-shirts are never my size. Okay, so do we have a further question?
Thank you for your talk. The question is regarding the iterative approach for like making an idea, implementing it, proving it with an A/B test. But what happens if you make another idea and on another loop you made another A/B test which proves the second idea but breaks the first one? So do you track some sort of like past results of the A/B test, or you have some sort of a baseline which you with which you can track your overall business goals?
So the question is tracking in terms of offline evaluation or in terms of A/B testing? Because in A/B testing, we actually use at the moment, we have 2 tests running in parallel because we want to have a lot of data in each of the groups, and we need to do the analysis on the experiment results. So it's going to be a tough part on the data analysis, of course. And in the offline evaluation, we don't have yet something in place to show us the numbers. And you mean like, okay, you have the date in August, and you have this number, and in September you have another number, and then you added another feature and something like that. We don't have it yet, but that's something we're going to implement on the offline evaluation cycle.
Do we have another question? Yes, sir. I think we need another microphone, maybe.
Yeah, thanks for the talk. So you mentioned that you have 12 discrete configurations that you want to test, right, with the offline testing. So have you considered framing that as an optimization problem where you could potentially, the question would be, what is my optimal configuration for these quality metrics? So instead of having a priori 12 configurations, you could say, I want to maximize this quality metrics, like NDCG or whatever, and what is my optimal configuration? Have you considered that? Or? Thanks.
We did actually consider working that way, but what we wanted to do in the first iteration is to be really in control of what we are doing. So we actually did, when we moved the step from offline evaluation to A/B testing, I showed you the query filtering slide. So what we actually did, we did also look into what we were filtering out and what we didn't filter out. So we did some manual evaluation of the query set, so we are really in control what's going to happen, because as Arne said in the beginning, the bigger the set of queries you're going to change, the higher the risk you're going to break something. So that's why I really wanted to be in control. But it's something to consider on in the future if we learn from the A/B testing data and then go into the next iteration, because you don't want to do this all time over and over again, of course.
Fantastic. Lucian.
Hello. Thanks for the talk. It was very interesting. So if I understand, you're applying the auto filtering. Is that OTTO filtering? So you're applying it to kind of automatically, you know, so it applies to facets and to results. So is it an option to apply it just, for example, to some of the facets, leave the results there, the most relevant are in the front, and leave, like, for example, one facet which is the department or something, just to show the diversity of the results, you know? So you auto-filter most of the facets, not the results, and some facets are not filtered. Or maybe filter the results, but not all the facets, or some combinations of this. Is this an option?
Yes, that's definitely an option. We didn't do it yet because I think the diversity question is really a good one, because that's one of the aspects we might be hurting. If we cut away too much of the diversity, we might hurt the user experience. But that's something we want to check out in the data first to see. Our hypothesis is that some of the queries will get much better by this auto filtering, and some we will turn worse. And missing diversity might be one of the reasons. So if we look at the data and we see diversity is really a problem, or the lack of diversity in the end, and then that might be a good solution to approach that. Yes.
Fantastic questions. Thank you. Yes, one more.
Hi, great talk. So I'm just wondering, I didn't see if you had any search suggestion or autocomplete. And did you, just wondering about that.
Did they have any? Do you have any search suggestion or autocomplete functionality?
Yes, we do have it, but it's not related to the feature here or to the implementation we did in the talk. Ah, you mean like implemented into the auto suggestion as a feature? Okay, yeah, sure. That would be possible. We didn't do it. We didn't think of it yet. It's a good comment actually to look into in the future.
Okay, I think we have time for one more question. Hey, Max.
How big is your quirky rules file? How many queries do you have in there, and how is it performing?
So just for the filters, it's like 40,000, and then we have synonyms and all the other stuff. I don't know.
Maybe 150,000?
Yeah, 150,000, but the performance is good so far. It's still fast.
Yeah, so obviously if you want to know more about the marvelous quirky tool, you should talk to Mr. René Kriegler, who happens to be sitting just here. Right, so we're going to take a quick break now, about 15 minutes. We'll be back at 11 o'clock. Thank you very much for our first two talks, our speakers.